Hello and welcome to the Raised Beaches podcast. I'm Dr. Evan James Gowan, but you can call me Evan. This is episode 2, and I'm filming it in a very special place, the Kikai Institute for Coral Reef Sciences. So Kikai Jima is an island in southern Japan. It's located in the Ryukyu chain. So the Ryukyu chain includes the most famous island is Okinawa, but this is a bit further north. It's close to an island known as Amami Oshima, but it's to the east of there. So the reason I'm here, of course, is because it's an interesting place for studying paleo sea level change. So Kikai Jima is a island with a rim of coral reefs around it, but also the island is uplifting, so it preserves corals from a lot of the time period between 120,000 years ago and present. Of course, they've published a book on the different kinds of corals that you find in this region, and it's all in Japanese, but there's a lot of different corals, and I'm only really just starting to know how to identify the different species, but hopefully this book will help. So I'm recording this on July 31st, and the first episode I recorded in June, and you're probably going to be listening to this in much later than that. But so some of this information is probably going to be a bit dated, but I think it's still interesting. So first off, the reason why it's taken a bit of time to get the podcast started is because I'm doing a lot of traveling. So at the end of June, I went back to Canada, where I'm from originally. And the reason I went to Canada was for a family event, but I also was invited to go to University at Buffalo. And I was invited by Jason Briner, who's a really well-known geologist who studies the Greenland ice sheet. And he invited me to go and visit because he was interested in what I do, which is, of course, modeling ice sheets in the past, as well as studying sea level changes. So he wanted to use the model of creating ice sheets that I wrote and use it in an educational context. So I will publish something to do with that pretty soon, and maybe even by the time this podcast comes out. The other person I met was Sophie Nowicki, who is involved in the ice sheet model intercomparison project. And what the ice sheet model comparison project is, they use a bunch of different models to try and figure out what the evolution of the Greenland and Antarctic ice sheets will be in the next 100 years or so, because they're, of course, interested on what that would contribute to sea level rise. This has a big society level importance. But these models are not necessarily telling you the same thing, because a lot of the physics behind ice sheet flow is not very well constrained, and there's also processes that are missing in a lot of ice sheet models. So Sophie was interested in asking me about how to sort out the glacial isostatic adjustment, which is to say how the Earth's surface will change due to the change in the loading of the ice on the surface. And in the past 10 years or so, it has become very clear that this is an important feature to determine how quickly glaciers will retreat in a marine environment. So basically, if the ice retreats, then the land will come up, and because of that, the amount of warm ocean water that will get underneath the place where the ice is touching the ground might be decreased, and that might reduce the amount of retreat of the glaciers compared to what you would expect if that wasn't the case. So we'll see how that goes. That will be in the next ice sheet model intercomparison project, and maybe I'll get involved if I have time. So the next thing I will talk about is that it's super hot. So the past week in Japan, it has been very, very hot, and in some places it's been exceeding 40 degrees Celsius, and that's approaching the hottest it's ever been in Japan. And where I live in Kumamoto, there were a couple of days last week where it was almost 40 degrees, and that's quite unbearable. In Kikai, we're surrounded by the ocean, so the temperatures are not quite as hot, but it is still quite hot, like mid-30s or so. And I've been making some videos that will be in a future podcast episode, and you'll see me very much covered in sweat while I'm doing these videos. So I hope people don't mind that. But I was also very covered in sweat, and I had to cool down before I started recording this. Yeah, it is very hot. And of course, Japan is not the only place that is hot. So according to the Copernicus Climate Change Service, which provides daily reports on global temperature, they expect that the hottest global average temperature that has ever been recorded happened last week. It might have happened for a couple of days. Of course, that's only exceeding the record highs that happened last year. So last year was there's a weather phenomenon called El Nino, and that generally will cause the global average temperature to be warmer because a lot of heat is coming out of the Central Pacific close to South America. So it's releasing heat out of the ocean, and that will cause the global average temperature to be higher. But of course, this is still much warmer than previous El Nino periods, and right now we're sort of coming out of the El Nino period and should be entering a La Nina by the end of this year. And if we think about that, we should be starting to cool down from that El Nino high temperature, but that hasn't happened yet, and that is something that scientists are a bit unsure of why the temperatures are so much higher than in previous years. So even compared to the El Nino La Nina transition just a few years ago in, I think it was 2016, it's still far warmer than what was before. And NASA also confirmed that this is definitely the hottest we've ever experienced, at least in recorded history. And on top of that, we're also seeing that the anomaly for sea ice area is also at a record low. It's not the absolute record low because usually that will happen in September when the Arctic ice cap reaches, or the Arctic ice, sea ice reaches its minimum extent, but if you sum Antarctica ice and Arctic ice, right now it's at a record low for this time of year. And this is being driven by an extreme heat wave in the India Ocean sector of around Antarctica. And of course, the global temperatures being at a maximum and the sea ice being at a minimum, those two things are probably connected. It's maybe a chicken or egg situation where maybe the sea ice being low causes the warmer temperatures, but maybe the warmer temperatures cause the sea ice to be not growing as quickly as it normally does. You know, it's maybe a feedback loop. So that's sort of how things go, though. There's these feedback loops that if you change the system in one way, it will accelerate changes and make sort of like a catastrophic failure of the sea ice. Maybe we'll see how things go in the next couple of decades. So we'll see, because it wasn't that long ago that the Antarctic sea ice area reached an all-time maximum, at least as far as the satellite records go back, which is into the 1970s. So it reached an all-time maximum, and now it's shrinking. So we'll see how that goes. And of course, the root cause of this extreme heating of the world in the past year, it's really something that's baffled scientists, because it was exceeding the record by a large margin. And one of the things that some scientists thought might be driving this is the Hunga Tonga eruption that happened in 2022. So you probably remember that there was this massive undersea volcanic eruption, and it caused this big sound wave to go around the world a few times, and there were tsunamis all throughout the Pacific. And this, because it was a volcano that erupted underwater, a lot of water shot up into the stratosphere. And if you put water vapor into the stratosphere, that will cause a net warming on the Earth, because it acts as a greenhouse gas. So there was a study that just came out by Schuberl et al. And they basically went through all the data that would be related to the atmospheric impacts of the Hunga Tonga eruption, which includes that water vapor getting into the stratosphere, but also things like changes to the ozone layer, and also aerosols, which is the particulate matter that comes out of the volcano. So when they summed all of these things together, what they found is that the net effect of that volcanic eruption was that it actually would have slightly cooled the Earth. But, it's a volcanic eruption, so it's kind of a transient event. So by the end of 2023, they say, well, the effects from this eruption have already passed. So this is not causing the extreme warming that has been observed. And so we're going to have to think of something else. Like it seems almost like it could be a step change. Of course, we're going to need to measure the temperatures for the next few years to see, but when we're thinking in the context of the goal to keep global temperatures to being within 1.5 degrees of the pre-industrial average, we're already almost there. And of course, temperatures will go down during the La Nina. That will probably happen by the end of this year, but it's looking more and more likely that within the next decade or so, the global temperatures will exceed that 1.5 degree threshold. The next component of that is Jasper et al. Recently put out a paper to put the 2023 extreme warming event in the context of the past 2,000 years. And they used two climate reconstructions. One is from instrumental records from the Berkeley Earth data set, which goes back to 1850. And that's a time when we started to have enough weather stations around the world to be able to estimate what the global average temperature was. And Jasper et al. Also used records from tree rings. So every year a tree will grow a ring, and depending on what the climate is, the width of that ring will change. So based on how wide these rings are, you can estimate what the temperatures were in the past. And of course, since trees really, especially in temperate climates, the trees only grow during the summertime, so it's a summer temperature proxy. And based on their reconstruction from the tree ring data, the temperature in 2023, the summer temperature, exceeded the range of natural variability that was estimated for the past 2,000 years. So basically, there's a range of possible temperatures because, of course, there's El Nino and La Nina cycles, as well as volcanic eruptions. So basically, in a stable climate, there's basically a range you would expect the summer temperatures to be in a global average. And basically, the 2003 summer temperatures were approximately 0.5 degrees above that range. So it really demonstrates how extreme the climate has become compared to the background variations. And of course, I'm from Canada, and we have this problem with the summer temperatures getting really hot. And in Canada, the past 2 years, there's been lots of forest fires. And there was a major forest fire in the town of Jasper in Alberta. And 1/3 of the town was razed by that fire. And the fire continues to burn and probably will continue to burn in that region for the foreseeable future, mainly because it's in the mountains and there's not really any way to extinguish it. And, I went to Jasper just before I started my PhD, which was in Australia. And the reason I went there is my cousin lived in Jasper, so that's one reason. But another reason is there's this highway which is known as the Glacier Parkway, and if you drive along the Glacier Parkway, which is between Lake Louise and Jasper, you'll see so many glaciers. It's really amazing. And of course, the most famous of the glaciers there is the Athabasca Glacier. And this glacier is very well studied, and it is the source of the water for the Athabasca River, which flows northwards through Alberta. And of course, it's been well studied, and what's interesting is that The tourist center is built on the moraine that formed at the maximum extent of the Little Ice Age, which was in the mid-1850s, I believe. And ever since then, the Athabasca Glacier has been retreating and melting away. And the retreat has been continuing, of course, and they've found tree fossils underneath the ice, and they've radiocarbon dated that, and those dates go to the mid-Holocene, when the global temperatures were sort of at a maximum. So that tells you that the Athabasca Glacier is already at sort of its minimum extent since the deglaciation happened. And it's continuing to retreat, of course. And you can visually see the retreat based on where the margin of the ice is, but also you can see it in terms of the thickness change. And as you retreat the margin, it's also changing, like the volume decrease has been quite substantial. So Jasper, in terms of it's being impacted by the fire, it's really terrible. And going along the Glacier Parkway, you can also very visually see the impacts of the warming that has happened in the past 170 years. So that is it for the introduction to this episode.